Today's experiment is numerical aperture of an optical fiber. Aim of this experiment is to determine the numerical aperture of an optical fiber and acceptance angle of the optical fiber. Apparatus required for this experiment: optical fiber cable, optical fiber transmission unit, numerical aperture jig with a screen of predefined ring diameters of 10, 20, 30, 40 and 50, and the patch cords. Numerical aperture of an optical fiber can be calculated using the formula. Numerical aperture is equals to sine of acceptance angle. The acceptance angle can be calculated using tan inverse d by 2l, where d is the diameter of the predefined rings and l is the length between the screen and numerical aperture jig. There is another method to calculate the numerical aperture and acceptance angle. Numerical aperture is equals to d by root over 4l square plus d square, and thereby acceptance angle can be calculated as I maximum is equals to sine inverse of numerical aperture. The procedure for this experiment: now take the first optical fiber cable, connect the optical fiber cable to the red LED source properly. Next, take the connecting wires. Here we have the power adjustment knob, and to this power adjustment knob there are 2 meters connections, M1 and M2 are there. M1 is the voltmeter, M2 is the milliammeter. Now connect the M1 positive terminal to the voltmeter positive, and M1 negative terminal is connected to the voltmeter negative, and M2 positive terminal is connected to milliammeter positive terminal. M2 negative terminal is connected to the milliammeter negative terminal. Now turn on the power supply. Set the power adjustment to the maximum. Now check the other end of the optical fiber cable. Is that light intensity is coming out of this cable or not? Numerical aperture is defined as the light gathering capacity of an optical fiber and is a measure of number of light rays. In this regard, when the other end of this optical fiber cable is focused to the screen which holds a predefined ring diameters, now focus the light. Maximum intensify light must confine to the a particular ring diameter of 10. Like we need to adjust the screen when this optical fiber cable is connected to the jig, numerical aperture jig. So connect this numerical aperture other end to this numerical aperture jig. Now place the screen on the numerical aperture jig at a particular distance, and now move the screen towards the numerical aperture jig as the complete light is going to be confined to the one particular ring. For example, if the light is going to be confined to the 20 millimeters of ring diameter, maximum intensified light is going to be confined to the 20 millimeters of ring diameter. Now find the distance between this numerical aperture jig and the screen. Now it is about of 22 millimeters. The observed distance between the numerical aperture and a zig is to be noted in a corresponding observation table, which holds the distance between the fiber end and the screen, and the ring diameters, as we already said, 10, 20, 30 and 40 and 50. So distances must be measured in a units of millimeters because the ring diameters are in millimeters. So now move the screen from the numerical aperture zig away. As it is moving away, then see that the light is going to be confined to the next predefined ring diameter. So it is 30 millimeters of ring is going to be holds the maximum intensity of light. Now the distance between the zig and the screen is about of 32 millimeters. The 32 millimeters you need to be mentioned in the corresponding observation table of the corresponding ring diameter. Like, repeat the procedure for all the predefined ring diameters and note down the values in the corresponding observation table. And using the formula, calculate the numerical aperture and acceptance angle for a given optical fiber cable.